Okay, so today we're going to be doing, my friends, multi-step equations. Yesterday we did one-step equations. So it was, y'all didn't see that? It was something along the lines of either this, but we were not using logic. We were trying to use mathematically how to solve for x, which if you recall, it was splitting the lines, splitting the sides, worlds, whatever, and then moving what needed to be moved so that there was all numbers to one side and all letters on the other side. In this case, the 2 needed to move because it wanted to get away from the letter and be over there with its buddy, the 5, the other number. So we minus 2, canceled out, minus 2 over there. And then we were done. X equals 3. That's called one-step equations for a reason. It's because all we really did was move one thing. Today, we are going over multi-step equations. So here is a very good example of a multi-step equation. The beginnings of multi-step equation. So, could you try to use logic here? Can you try to find what x is? What would x be? What would x be? Let's...
Second power?
No. What number could x be so that all of this right here on this side, if you were to plug in a number in for your x's, would come out to 25, equaling 25. Well, for the one-step equations, like I said, it's easy to do. You could just see. But with multi-step equations, I mean, give it a go. Try to tell me what x is. Well, you could probably find it through lots and lots of trial and error, right? Putting in, I don't know, a 2 first, then putting in a 3, then putting in a 4, right? Until eventually, on this side, you come up with 25. Because that's the end goal. You're just trying to come up with something equaling that same something. That's all you're trying to do. So we don't like to do stuff by trial and error. We use mathematics to our advantage. So multi-step equations, all it is steps, my friends. You follow the steps, you remember the steps, you learn the steps, and your life will be very, very simple when it comes down to equations. First things first, locate your equal sign, just like yesterday, and build yourself the wall. Separating 2 worlds, 2 sides, 2 whatever. So now that we've constructed our wall, before, with one-step equations, we would just immediately start rearranging. The thing is, there technically is a step before that. Before you start moving stuff from here to there or vice versa, there is something you must always check. And even with one-step equations, you were supposed to check. But I didn't tell you to because none of the questions from yesterday's worksheet had this. But here, it does. Before you start moving stuff and rearranging all like terms to its designated area, you want to ask yourself, step number 1, always ask yourself, are each side of is each world or each side or whatever you want to think of it, is each side as simplified as possible? So this is what we do here, my friends. Let's say we were to block off, let's say we were going to just completely, block off this whole side of the equal sign. What if we just block this off? And all we do is look at this side, the left side. 6x plus 5 minus 2x. Just I mean, obviously, for those of you doing this on paper, you would get your hand and physically cover this side. Cover it, and then just see this side A. And then what you're going to do, just looking at this side, you are going to use your skills of math, everything we've learned up until this point, you're going to use that newly found skills of yours to simplify whatever it is on this side. Sometimes it could be a standard addition problem. It could be, in this case, hint, hint, combine like terms. It could be distribution. It could be FOIL. It could be everything that we've learned up until this point, my friends. Your goal is to, whatever it is on each side, make sure it's as simplified as can be. So let's look at this side right here. What do we want to do to simplify this side down a bit?
Combine the like terms 6x and 2x.
Perfect. Combine like terms. If you forgot what combine like terms were, it was this. You found your two like terms, and guess what we do? We combine them. Tell me, what is 6x minus 2x? It is, my friend, just 4x. 6 minus 2 is just 4. So it's 4x plus 5, because this 5 just gets brought down, right? And now tell me, is there anything I can do here? Is there absolutely anything else that I can do to simplify this side? 4x plus 5. No, there isn't anything else that I can do. So guess what? You're done with that side. Now just go to the other side. So block all of this off. Look at this number right there. Is there anything I can do? No, it's just a number, my friends. It's just a measly little 25. There ain't no 25 squared. There ain't no 25x plus 2x. There is no 20. There's just a measly little 25. So that gets brought down. So now both your sides are as simplified as possible. That, my friends, is without a doubt an important step. And it is going to be your first step. That's your step number 1. Well, technically your step number 2. Your step number 1 is building that wall. Always draw that line first. Draw your line. That should be your first thing. Second, simplify each side. So that's your couple steps right there. Now that you've determined that each side is as simplified as possible, guess what we do? Now we start arranging. Now we start moving stuff from one side to the other, from the other side to the other. Again, trying to rearrange it so that each side has its own like terms, pretty much. All numbers to one side, all variables to the other side. So tell me, what could we move here so that the worlds are happier? It won't be 100% happy yet, but it'll be somewhat happy.
Plus 5.
So this plus 5, there's a letter there, right? There's a number there, there's a number there. Those numbers want to go over there with the other number, right? It wants to be far away from your variables. So yes, you do move the plus 5. But if you're one of those students that said, I want to move the 4, I mean, you're not wrong. The 4 will want to go away from the letter, right? But the thing is, the letter that's attached with the variable, make that your last step. Because the only way to detach that is by using division, remember? Division will be your last step. So don't worry about that 4 just yet. Move all the excess fat that's around it. So the 5 is going to be the first thing that we move. So tell me, how do you move the 5?
Move it to the other side, put a minus on it.
Minus 5 cancels out. It gets thrown over there. Now we're left with 4x equals 20. Now, could somebody tell me what we need to do? What was it? Now you get rid of the 4. You've determined that you want to take the 4 out. So now you do take the 4. How do you take the 4? You divide. Cancels out, gets thrown over there. My friends, x equals, what's 20 divided by 4? You just found your x. So let's recap. Step number 1, split the worlds. Step number 2, or step number 1, if you still want to think of it as step number 1, simplify each side. Then step number 3, or 2, start moving stuff accordingly. Keep it in mind that if you have to resort to dividing to detach the number from the variable that are together, that should be your last step. Move any random stuff that might be around first. Don't worry, my friends, we're going to do more. This is your first example. Let's do the next one.
I got a question.
Yes.
So is it kind of like using pandas in a way?
Clarify. What do you mean by that?
Well, so it's like parentheses, there's none of that. But if you have to circle each like term or whatever, that'd be kind of like a parentheses, right? Around each one of them. So pandas and then you.
We find the price
So.
5, or we can put it on.
So, actually, I shouldn't have moved on anyways. I should have showed you that. So, we came up with x equals 5, right? And you said you must always check whether your answer for your variable x is correct. You must always check. How do we check? Well, you said it. Plug it back into the original problem wherever there's an x, right? At this point, this is straight up evaluating expressions, which we did in week 3 or 4, which, I don't know, one of the two, right? We did that already. So you should know 6 parentheses plus 5 minus 2 parentheses. Then we plug in our 5. Somebody please tell me, when you punch all of that into the calculator, what do you get? You get 25. And that's how you know it's correct. Do you know why? Because the original problem, if we look at it right here, it was 6x plus 5 minus 2x should equal 25. So it technically looks like this. Is this a true statement? That's true. 25 does equal 25. If it was anything else, 20, 24, 26, 27, it's wrong. Because that doesn't make sense. How can 26 equal 25? Equals is equivalent. It's just full-blown the same thing, right? So you're always looking for the same thing on each side. And we're going to do that from this point forward. Thank you for reminding me of that, because for the next example, we're going to solve it the way we just did, but then we're also going to check our answer. And you're going to see again how you could always check your answer. So here I have negative 4, x minus 6 equals 2x. I'm about to blow your mind right now. I am about to blow your mind with this one. So, what's the first step?
Make the wall.
Make the wall. Then simplify each side. All right, is there anything I could do on this side? What could I do? What was it? Exponent? Oh, yeah. Distribute. Distribute or multiply the polynomials, whatever, right? If you're thinking, aren't I supposed to do what's inside the parentheses? Well, yeah, but could you do what's inside the parentheses? No, we learned that last week. Yeah, this was last week's quiz right here, distribution. So, we can't do what's inside parentheses, but we can distribute. So tell me, what's negative 4 times x? Negative 4x. What is negative 4 times negative 6? Positive 24. Nice catch. Equals 2x. All right. So, well, I jumped ahead. So this part is done, right? Because there's nothing else to do. Always check the other side whether there's anything to do. Is there anything you could do on that side? No, it's just a 2x. There's no sort of operations. There's no sort of anything. It's just 2x. So bring it down, 2x. So now my new equation so far looks like negative 4x plus 24 equals 2x. Okay, good. So step number 1/2 is done. Now we move on to the next step. Arranging all like terms to its designated area. This is where I blow your mind right here. What needs to be moved so that the worlds are somewhat happy? The 2? The 2x? Or the 2?
4x.
So, here's the thing. Definitely this 24, it cannot be moved. If you move it the 24 to this side, it's not happy. It just got thrown into another variable, right? This 2x, it would be happy if it came over here because it would have its buddy 4x, but there's still the problem of the 24. This 4x though, the whole 4x wants to be moved over there to be with its like term, the other number with a variable. I know right now you're thinking, aren't we just supposed to move all one side just numbers and the other side just letters? No sort of mix and matching? I'm like, yeah. That's what we're trying to get to, but there's a process to it first. Step number 1 for that process is to first move all like terms to each designated area. So we aren't just trying to move the 4. We aren't just trying to move the x. We're trying to move this whole 4x over there with its other like term, the 2x. So now comes the biggest question. How do you move this whole 4x? How do you move the whole 4x? You do add 4x. So this is where people always say, don't I divide by 4x? No, there's no such thing. If you divide by negative 4, that's just to separate the number and the variable from the variable and just move the number over. But that's not what we're trying to do. What we're trying to do is move the whole thing, the whole term. How do you move a whole term? The same thing you do to move a whole number. It's just do the opposite of the sign to the left. You add 4x, that cancels out. And guess what? It gets thrown over there. 2x plus 4x is what?
6x.
So now I have 24 on this side equals 6x. Did you see what we did? We moved all like terms with each other. We want to move all like terms to one side so that they're kind of happy. Kind of. Right now though, even though we just combined our like terms, there's a little issue going on. The fact that this letter still happens to have a number next to it. Remember, letters at the end of the day hate numbers. Letters hate numbers, so we need to move what?
6 by dividing it from the x.
Exactly, the 6 that needs to move. How do you move the 6? In this case, dividing, because in this specific case, we are trying to detach the number from the variable. So here is where we divide, cancels out, and it gets thrown over there. 24 divided by 6 is what? 4. 4 equals x. And just like that, you aren't done. Because you have to make sure you have the correct answer. So this is what you do. You get your 4 for your x. And you evaluate your equation. So negative 4, parentheses, parentheses 4. Sure, in this case you don't need those parentheses again because your x is positive. But make it a habit. You know. Make it a habit still. Till this very day, make it a habit. Somebody tell me what this side, with that 4 in for x, what does that come out to be? Was it? What?
4. It's going to be negative 16 plus 24, which will be
Well,
8.
4
8.
yeah.
Negative 16 plus 24, which is 8, and 2 times 4 is 8. So 8 is equal to 8.
Yeah, so 4 minus 6 gives me my negative 2, right? Negative 4 is out here. Negative 4 times negative 2 is positive 8. So this side becomes positive 8. What does this side become? What's 2 times 4? 8. So that's when you know your x is correct. 4 is the value for x. All because you checked your answer. There should be literally on the quiz, on the worksheets, there should be no hesitation. You should, after each problem, check your answer, same way I did. And if you aren't getting 2 of the matching ones, something equaling that same something, you know you did something wrong within your math. And most likely, the issue of what's going to make your math incorrect is this part right there, is accidentally dividing when you're supposed to add or subtract, or accidentally adding and subtracting when you're supposed to divide. You're just going to get everything confused. But through practice, you will do fine. Let's do one more problem. This one being the king of all equations. The king of all equations right here. This is the standard one that's seen almost everywhere when it comes down to multi-step equations. Let's see if I could create one at the top of my head. If this one, get your calculators ready because I'm the one creating it, it might come out as a decimal. So we'll have to do a lot of calculations. But I'll try my best not to. I like sticking with even numbers so that I avoid that. No! Okay, we got a couple seconds. No. 8x minus 6. No, I gotta watch out here. Okay, here we go. Okay, so let's see whether this comes out good. What's my step number 1?
Wall.
Build the wall. Okay, so tell me, what's the next thing that we got to do? Simplify each side, right? All right, so let's simplify this one just because it's our first one. What can we do here?
Can't do anything inside the parentheses, so you gotta distribute.
Distribute out 2x, 2 times x, and then 2 times negative 6. So that becomes 2x minus 12. Bring down the rest of the stuff. All right. Is that as simplified as it can get down to? What else could we do? I see some like terms that we can combine, right? So it's 2x plus 2x. Good. So This one could continue being simplified, which comes out to be 4x minus 12. Am I correct? Good. Now, is there anything else I could do here? So jump to the next side. Is there anything I could do on this side? No, which means we're done with our step number 1/4. 2. We are done with simplifying each side. So now, at this point, this is what I wanted to show you. This is standard in math. They love giving these problems. I've told students countless times over the past couple quarters how if you want to call this exact thing that you're looking at, I tell students to use their name to help remember this exact problem here. For instance, my name is Neil, right? When I see this type of problem, I know I'm going to have to use something called the Neil exchange. Because what we're going to do is exchange something. Why use my name? Because it just helps me remember. Jason, you're going to use the Jason exchange. Lucetto, you're going to use the Lucetto exchange. Whatever helps you remember this little trick that we're going to do. Think about it. What needs to be moved? Well, we know like terms need to all be set aside, right? We know we want all like terms in its designated area. So what we do is the exchange. Think about it. This 4x here wants its buddy 8x with it. But this negative 4 here wants its buddy the negative 12. One of them are prisoners of war. Think about it. This 4x says, hey, negative 4, give me my buddy 8x, bring him over here, and then I'll exchange you your little buddy, your number, and I'll throw him over to you. It's the exchange, my friends. This is common in multi-step equations. You're going to come across this a lot. So, think of it like that. But this is where the problem comes into play. Which one do you do first? Psst, it doesn't matter. You're always going to get the correct answer. For instance, let's say I'm the student. Let's say I'm a student that says, Neil, I want to move the 4x over there to the 8x. Okay, you move the 4x, cancels out, and it gets thrown over there with its like term, the 8x. By default, the exchange, the Neil exchange in my case, tells me I then must exchange this 4 over here, canceled out, and throw it over here with the 12, right? We did a little exchange. And now we just literally do what we need to do. Negative 12 plus 4, what does that become? Negative 8 equals, what's 8x minus 4x? 4x? Oh man, this is going to come out nice. A full whole number. This is beautiful. So what do I do here? You divide by 4, cancels out, gets thrown over there, and next thing you know, negative 2 equals my x. You found x. But wait, what if you were one of those students that over here, when we were looking at our little dilemma of, what was it? 4x minus 12 equals 8x minus 4. Again, I was the one that said move the 4x over here and then move the negative 4 over there. The Neil exchange. What if you were one of those students that said, man, throw me the 8x over there and then move the negative 12 over there. Guess what, folks? You come out with the same exact answer. It doesn't matter. As long as you follow the exchange, as long as you trade one for the other and move all like terms to its designated area, you will get the correct answer. How about we do this one? What if I do move the 8x over there by minusing 8x? Cancels out. And then this little guy, the 12, you add 12 to cancel out, to throw it over there. Now you solve. 4x minus 8x, what does that become? Negative 4x equals negative 4 plus 12? Positive 8. What do we do here? Huh? Divide by negative 4. Cancels out, gets thrown over there, negative 4. X equals, what's 8 divided by negative 4? Negative 2. Both the same exact answers. The reason why I went through all this is to really show you that the way that looks, the way that this looks right there, you're going to come across a lot of the times. But when you see it, do whatever it takes. Like I said, the trick, use your name. Literally, do any sort of thing that helps you remember the way that looks, and having in your head, having your brain tell you, oh, this is that whole exchange trick in which you got to move all like terms to its designated area. Whatever it takes to help you remember that, do it. And then at that point, you're just moving stuff left and right so that you could be done with it. My friends, does anybody have any questions? No questions? One quick one. One really, really quick one. One really, really quick one. So, split the worlds. Let's do this side first. Is there anything I could do on this side? What can I do?
What side?
This side right here. Hmm? Well, think about it. Yes, you're right. Don't let this weird thing trick you. If there was a 2 out here, you would know exactly what to do, right? You would know you'd have to distribute. But you're getting tripped up because of that. There isn't a number there. That's what's tripping you up, right? But guess what? What number is there?
1.
There's a 1. So I'm showing you this now so that in the worksheet you don't forget about that. There's always a 1 there. We distribute out the 1, which, yes, comes out to be almost the exact same thing, except as negative 1 times x is negative 1x. Negative 1 times positive 2 is negative 2. So that side is done. Equals, what can we do on this side? Just a simple little power. What's 3 squared? Huh? Nobody thinks it's 2? I mean 6? Nobody thinks it's 6?
9.
Good, it's 9. Remember, it's not 3 times 2, it's 3 times 3. Creating 9. Alright, now what I do? Let's solve this. I saw somebody mouthing it. Plus the 2. Cancels out, plus the 2. Negative x equals, what's 9 plus 2? 11. Negative x equals 11. Am I done? X equals 11. Isn't that what I'm seeing? No, my friends. You remember the trick with yesterday? You aren't done until your variable is positive. So, what do we do here?
Divide it.
Divide by? Yeah. You could do that. Divide by the negative 1 that happens to be there. There's a 1 there, right? You divide it out, throw it over there, and next thing you know, x equals negative 11. That was the whole division one. Remember, in case you ever have a negative variable, you could also use the little Neil trick that I taught you. Just get the negative, throw it to the other side, and put the sign to the other side. But I think it helps to have this in your head because it develops your skills of, again, moving stuff from one side to the other. So, my friends, that being said, we are good to go. I am going to give you all the worksheet, and then you are free to have fun.